Okay, 3.3 is on trigonometric substitution. So we're going to use trigonometry as our U in a way to try to substitute in for some values so that I can use the properties of a right triangle to help me solve some integrals. So trigonometric substitution. So if in the integral we have the following expression, then we're going to use the following substitution. And then we're going to use the following identity to simplify the substitution. Okay, so if we see in our integral something that looks like the square root of a squared minus x squared, okay, where a is a constant, okay, it's the square root of a squared minus x squared. The substitution that we're going to use for that is going to be x equals a sine theta. And the identity that we're going to use to simplify this is 1 minus sine squared theta equals cosine squared theta. Okay, if we have the expression a squared plus x squared, we're going to use the substitution a tangent theta. And the identity that we're going to use there is 1 plus tangent squared theta equals secant squared theta. Okay, to simplify that guy. And if we have the square root of x squared minus a squared, kind of backwards here from the first one, we're going to use x equals a secant theta. Okay, and the trig identity that we're going to use for this one is secant squared theta minus 1 equals tangent squared theta. Okay. So let's jump right in. Let's try to evaluate this integral, square root of 9 minus x squared all over x squared dx. Okay, so this looks like expression number 1 here, the first expression, where I've got a squared minus x squared. Okay, I can look at a right triangle, say that I didn't remember what to substitute in. I can actually get these values from a right triangle and looking at the Pythagorean theorem. So if we look at this expression, the square root of 9 minus x squared, that reminds me of like c squared minus a squared square root is equal to b. Okay, if I were to solve for the Pythagorean theorem, okay, for a side, then I would get that type of an expression using my right triangle. Okay, here C is the hypotenuse, and so in our expression 9 minus x squared, let me write that a little bit better. 9 minus x squared, the C corresponds to 3, and so I'm going to put a 3 for my hypotenuse. The A corresponds to x, and so I'm going to put a little x there for my leg. And the B is going to correspond to this expression itself. When I solve, it'll become that. I'm going to let this angle be theta, and we will see that the sine of theta does equal x over 3. Okay, or x is equal to 3 sine of theta. So again, if you don't remember which substitution to use, you can derive it. Okay. We don't generally use cosine as our substitution or cosecant just because those will make things go negative and we like to keep things positive. However, we could use those as substitutions and they would just give us cotangents and sines in the very end. But again, we like to keep things positive if we can, so we try to stay away from cosines and cosecants. Okay. Okay. So the substitution that we're going to work with is we're going to say, okay, the sine of theta is equal to x over 3, or x is equal to the sine, or sorry, 3 sine theta. Okay, that means that when I take the derivative dx, I get 3 cosine theta d theta. Okay, that'll be very important. Okay, to get, this is my integration factor that I need to make sure that is in there. Okay. So let's use this as our substitution, as our kind of u substitution. So what is this going to look like? Well, I'm going to get the square root of 9 minus x squared. Well, what was x? X was 3 sine theta squared. Okay, all over another x squared, that's 3 sine theta squared. And then I need my dx. Well, my dx is going to be my 3 cosine theta d theta. And now we're going to clean this up. Okay, so we're going to integrate the square root of 9 minus, I'm going to square this out. This becomes 9 times sine squared theta all over 9 sine squared theta times 3 cosine theta d theta. I'm going to factor out a 9. I get the square root of 9 times 1 minus sine squared theta all over 9 sine squared theta, 3 cosine theta d theta. Okay, and now we can use that substitution. 1 minus sine squared is cosine squared. Okay, we can use that, I should say, identity. So this is going to be 9 times cosine squared theta square root all over 9 sine squared theta times 3 cosine theta d theta. Okay, but what is the square root of 9 cosine squared? Well, it's just 3 cosine. So this is the integral of 3 cosine over 9 sine squared theta times 3 cosine theta d theta. Let's keep on going. This is going to be 9 cosine, there's a theta there, cosine squared theta over 9 sine squared theta d theta. And the 9s are going to drop out. And I get cosine squared over sine squared, which is cotangent squared theta d theta. Okay. So to integrate cotangent squared, you know, nothing, the derivative of something is not cotangent squared, but the derivative of cotangent is cosecant squared. So if I can get that cotangent squared to look like a cosecant squared, then I'm good. Okay, and so I'm going to use this identity. 1 plus cotangent squared theta equals cosecant squared theta, which tells me that cotangent squared theta is equal to cosecant squared theta minus 1. And so we're going to take this and change this guy into cosecant squared theta minus 1 d theta. Okay, because the integral of cosecant squared is cotangent. I'm sorry, negative cotangent. So this is negative cotangent theta minus the integral of 1 is theta, okay, plus c. But now I've got to figure out, okay, well, what is theta and what is cotangent theta? And the way I do that is I go back to my triangle for cotangent theta. What was cotangent theta? Looking back at my triangle, I need cotangent theta. Okay, well, cotangent is cosine over sine. Okay, or x over y. So this is going to become, okay, the square root of 9 minus x squared all over x. Because that's the cotangent is the adjacent over the opposite. The adjacent over opposite. And so we're going to say, well, this is negative the square root of 9 minus x squared all over x minus theta. Well, what's theta? Well, in the very beginning, we let the sine of theta equal x over 3. Okay. So this implies that theta is equal to the inverse sine of x over 3. So we're going to plug that into our solution here. So the inverse sine of x over 3 plus c. And that's about it for that one. You cannot leave your answer in terms of theta. You must go back to your original x and make it in terms of x. If you have a trig value in your solution, if you have a trig function in your solution, you must put that back in terms of x using your triangle. Okay. Okay, any questions on number 1 so far? Okay, number 2. Okay, find the integral of 1 over x squared times the square root of x squared plus 4 dx. This is addition, okay, which in my mind says, hey, I'm probably going to end up with a tangent here. Okay, tangent theta as a substitution. Okay. Okay, if I draw my triangle to try to get the addition here, okay, I'm gonna say, well, I want to go for a tangent theta. Okay, so a tangent theta, so that would be opposite over opposite over adjacent. And so to make things easy, I'm going to let this side be x. I'm going to let this side be 2. And then the hypotenuse ends up being the square root of x squared plus 4. The reason that I let this side be x is that it works well to solve for x. I don't have to divide by tangent theta. Okay, I can just say, hey, tangent theta is equal to x over 2. Okay. So when I multiply both sides, I say, oh, x is equal to 2 times tangent theta. Okay, so when I take the derivative dx, I get 2 secant squared theta d theta. Okay, so now I can plug in for my substitution. X squared, that's going to be 2 tangent theta squared times the square root of 2 tangent theta squared plus 4. Okay, times dx. But what was dx? It was 2 secant squared theta d theta. Now I'm going to square this out in factor to get 1 over 4 tangent squared theta times the square root of 4 tangent squared theta plus 4 times 2 secant squared theta d theta. Okay, and then we've got the integral. I'm going to factor out this 4 on the bottom, this one and this one. Okay, so we got 1 over 4 tangent squared theta times the square root of 4 times tangent squared theta plus 1, okay, times 2 secant squared theta d theta. Okay, but what was tangent squared theta plus 1? It was secant squared, right? Okay, so this thing becomes secant squared. Okay, from our Pythagorean identities. So this is going to go 1 over 4 tangent squared theta times the square root of 4 secant squared theta times 2 secant squared theta d theta. Okay, the integral, okay, of this thing becomes 1 over 4 tangent squared theta. This is going to be 2 secant theta, and then it's multiplied by 2 secant squared theta d theta. Now, one of these secants is going to cancel, and this 2 is going to cancel, and I can pull the 1 out of 4 on the outside. Okay, so this becomes 1/4 times secant theta over 4 tangent squared theta. Oh, sorry, we got rid of the 4. Over tangent squared theta d theta. Okay. Well, again, if I try a regular U substitution on this, it's not going to be too helpful. If I try to let U be tangent, that will get me a du of secant squared, but I don't have any secant squareds. I just have a secant. So what I'm going to do is I'm going to turn all of this into sines and cosines and see if I can muscle my way through using sines and cosines. So let's go 1 over cosine theta all over sine squared theta over cosine squared theta d theta becomes 1/4 times the integral of 1 over cosine theta times cosine squared theta over sine squared theta d theta. Okay. And again, one of these cosines is going to cancel. And so I'm just left with 1 over 4 times the integral of cosine theta over sine squared theta d theta, which this does lend itself to a really nice U substitution because the derivative of sine is cosine. We're going to say, okay, U is equal to the sine of theta, du equals cosine theta d theta. So this becomes 1/4 integral of 1 over U squared du. Okay, so that's nice. So this is 1/4 integral U to the negative 2 du. So we want to add 1 to this and then divide by the exponent. So this is going to become U to the negative 1 over negative 1. Okay, times 1/4. Okay, plus C. Okay. So this is going to become negative 1/4 U to the negative 1/4, that's 1 over U plus C. But what was U? Well, it was back here, it was sine theta. So we did a U substitution on a trig substitution. So we actually have to go 2 steps back here. We're going to say, well, U, we've got to go back to theta, and we've got to take that back to x. Okay, so we've got to leave things the way we found them. We found them in terms of x, and then we did a trig sub using theta, and then we did a U sub on the trig sub. So we've got to go take this u, 1 over u, and say, well, that was sine of theta. So this is negative 1/4 1 over sine theta plus c. Okay, well, what is 1 over sine theta? That's cosecant. So this is 1/4 cosecant theta plus c. So now I've got to figure out, well, what's cosecant of theta? Well, cosecant of theta, okay, is the reciprocal of sine. Sine is opposite over hypotenuse. So this should be hypotenuse over opposite. So I've got to go again back to my triangle, right, that I made. I had x and 2, and then we had x squared plus 4 square root. So what is cosecant? Cosecant is going to be hypotenuse over opposite. And so this becomes negative 1/4 times hypotenuse, which is x squared plus 4 over the opposite side, which is x plus c. And maybe I'll write it like this: negative square root x squared plus 4 over 4x plus c. And I'm done. Okay, let's try another one. Okay, number 3. Okay, the integral of 1 over the square root of x squared minus 25 dx. So for this one, let's draw our triangle. Okay. So it looks like x is going to be my hypotenuse. Okay. And then 5, I need 5. Okay, so I have a choice on where I want 5 to go. I could put 5 there, and I could put the square root of x squared minus 25 down here. However, what is that going to give me? That's going to give me to get x over 5 would have been cosecant, and I don't want cosecant because I want to keep things positive. I'd like to use secant, not cosecant. Okay, because the derivative of cosecants gives me negative cotangent squareds. I'd like to, or sorry, negative cotangent, negative cotangent cosecant. And what I want is the derivative of secant to give me secant tangent to keep things positive. So I'm going to swap these two, okay, to make sure that x over 5 gives me the opposite of cosine. So that's going to be the square root of x squared minus 25. Okay, and so we can say that our secant theta is equal to x over 5. Okay, that tells me that x is equal to 5 secant theta. So that means that our dx is going to be 5 secant theta tangent theta d theta. Okay. Okay, so let's do our trig sub. 1 over the square root of x squared. Okay, so x is 5 secant theta quantity squared minus 25 times my dx, which is 5 secant theta tangent theta d theta. Okay, let's square this out and distribute, or and factor. So 1 over the square root of 25 secant squared theta minus 25. I've got 5 secant theta tangent theta d theta. Okay, I probably could have just put that on top. at this point, but we'll keep it there for now until the numbers cancel. Okay, this is going to give me the square root of 25 times secant squared theta minus 1. Okay, which is nice. Okay, because secant squared theta minus 1 is tangent squared theta. Okay, so I'll move that down. I'm going to put the 5 secant theta tangent theta on top, d theta, and then secant squared theta minus 1 is tangent squared theta. Okay, that's my trig identity. Okay, so this becomes the square 5 times the secant theta tangent theta times the square root of 25, which is just 5. Well, times the square root of secant squared minus 1, which is tangent squared theta. And theta, those 5s are going to cancel out. And then this on the bottom is going to become a tangent theta. And so this becomes secant theta tangent theta over tangent theta d theta, which just leaves me with a secant theta, which is nice because last time we talked about how to get the integral of secant theta, and we used a integration buddy technique to get that, but you can just memorize that this is the natural log of secant theta plus tangent theta d theta. We don't have to go through deriving that is in itself is an identity. The integration of tangent theta is natural log of secant theta, and then the integral of secant theta is natural log secant theta tangent theta, I believe. And we already integrated, so we don't need the d theta, we just need a plus c. Okay. But we can't stop there. Okay, we need to now go back and say, well, what is secant theta and what is tangent theta in these terms? Okay, well, secant theta was x over 5. Okay, tangent theta, looking at our triangle, all the way back to our triangle, what is tangent theta? Tangent theta is opposite over adjacent, so that's the square root of x squared minus 25 over 5. So tangent theta is equal to the square root of x squared minus 25 all over 5. Okay. So this is going to equal the natural log of x over 5 plus the square root of x squared minus 25 over 5 plus c. Let's put this over a common denominator. So natural log of x plus square root of x squared, it's minus 25 all over 5 plus c. Now I'm going to use the property of natural logs to say that this is the natural log of a quotient is the difference of the natural logs. So this is x plus the square root of x squared minus 25 minus the natural log of 5, which is just a constant. So that kind of gets absorbed into my plus c. Okay, this is just plus c. It's a constant plus another constant is just a constant. Okay, so this is going to be equal to natural log of x plus the square root of x squared minus 25 plus c. Mhm. Okay, any questions on number 3?
If we were given a question similar to that, would we need to simplify it so that natural log uh would be like differential, and then we would just do plus c? Or is it okay to have the quotient or the fraction? Because they're both correct.
They are. I mean, you always want to simplify as much as possible. So, I mean, I would argue that my answer is most correct.
I see.
Do you mind explaining where the natural log is coming from again?
Right here,
Yeah,
sure. I can do that by looking at the notes from last time. So if we go back to 3.2, you look in your notes from 3.2, we did the integral of tangent x, okay, was the natural log of secant x plus c. And then we did this guy here, number 7. Okay, and I said, well, grab your integration, buddy. And then we know that the bottom, notice that the bottom is the top is the derivative of the bottom. And so we just do a u sub on 1 over u, which gives us a natural log. And so I said the integral of secant x is natural log of secant x plus tangent x plus c, which is an identity. Okay.
right. Thank you.
Okay, any other questions before we move on? Okay. Let's go on to number 4. And we've got the integral of x over the square root of x squared plus 4 dx. Okay, this one looks like a trig sub, but it's not. Okay, it's a little deceiving because we could use trig sub on here if we wanted to, but we don't need to, is the thing. So this is a regular u sub. Okay, used here. Because the bottom, if I take the derivative of the bottom, I get, 2x and I get 2x dx, and so I have x dx on top. So this one becomes pretty nice in that it's just u is equal to x squared plus 4, even though it looks like it would be a u sub, it doesn't have to be. Okay, and so we can say, well, du is equal to 2x dx. So divide by 2. And so we're going to get du over 2 is equal to x dx. So the integral is going to be 1 over square root of u times du over 2. And so this is u to the negative 1/2 times 1/2 du. This is going to go to, if I add 1 here and integrate, if I add 1 to the exponent, I get 1/2. The reciprocal of 1/2 is 2. So this becomes 2u to the 1/2 plus c. Those 2's cancel out. I'm left with the square root of u plus c. But what was u? U was x squared plus 4 plus c. Okay, now, if you wanted to, you could do this using a u sub. I'm sorry, using a trig sub. But again, it's a lot more work. So if I wanted to use a trig sub, I would use x equals 2 tangent theta, okay, as my trig sub. I could plug that in. I would get 2 tangent theta all over 4 tangent squared theta plus 4 square root d theta. Oh, no, that's not d theta. I need my dx to be 2, the derivative of tangent is secant squared. I would need a 2 secant squared theta d theta, okay? Over x squared plus 4, okay, that looks good. Then we want to integrate 4 tangent theta times secant squared theta d theta all over, this is going to become the square root of 4 times tangent squared theta plus 1. So tangent squared theta plus 1 is secant squared, is that right? Yeah. So this is going to become the integral of 4 tangent theta secant squared theta all over 2 times the square root of secant squared theta d theta. Okay, nice. And so this becomes the integral of 2 tangent theta secant squared theta d theta all over secant theta. So that cancels there. I'm left with the integral of 2 tangent theta secant theta d theta. Okay. So what do I do at this point? Can I change it to sines and cosines? Yeah, let's do that. So this is 2 times the sine theta over cosine theta times 1 over cosine theta d theta. So this is 2 times the sine of theta all over cosine squared theta d theta. Okay. Okay, so now we're going to look at getting a u sub here. U is equal to cosine theta, and so du is equal to negative sine theta d theta. Okay. And so, -2. Okay, 1 over u squared times co that
Isn't it that we take the 2 out and then we just take the integral of tangent secant because we know that it's secant because of our helper buddy? I think.
let me think about that for a second. So the integral of secant tangent is secant. Yeah, I guess you're right. It is secant. Yeah, so that's a good idea. Okay. So yeah, we can go directly to that because that's on our I guess I'm kind of doing it the hard way. Because I didn't see that. You could do it that way, the way I was doing it. But we can take the 2 out. The integral of tangent theta secant theta, e theta is just secant theta plus c. So that's 2 secant theta plus c. But what is secant theta? So if we look at our original triangle, okay, we had tangent theta equaling x over 2, right? Okay, so that's going to be this guy, that's going to be this guy, and then this guy is going to be x squared plus 4, right? So what's secant? Secant is hypotenuse over adjacent side. So this is going to be 2 times the square root of x squared plus 4 all over 2 plus c. The 2's cancel, and I am left with the same thing here, x squared plus 4. So that, yeah, that was a quicker,
Yay.
yeah, a quicker one. So
Hey.
thank you for that help. Again, you could derive it changing it to cosines and sines, because the negative would cancel out because you would end up with a -1 when you integrate. And so the -2 would cancel and you'd be left with the 1 over cosine, which is secant. And so you would still be left with the same thing. Okay.
I see.
Okay. So who said that? Was it was it you that said to go this route?
Yes.
Okay, good job. Nicely done. Nicely done. Yeah, a little bit quicker of a route. Thank you. Okay, so again, it can be done using a trig sub, as you can see, but again, why go through all that extra work? You don't need to. Okay, sometimes the denominators aren't nice, and so we have to kind of make them nice. So let's look at number 5 here. We have the integral of x over the square root of 3 minus 2x minus x squared, okay, dx. And so what we need to do in this case is we need to complete the square. Okay, we need to get it into something that looks like this, a squared minus x squared. Okay. And so I'm going to complete the square on this guy. This is going to become 3. Okay. Let me factor out the negative here from those 2 terms there. 3 minus. Okay. And then this is going to become x squared plus 2x plus something that I would have had to add to complete the square. And then because this is subtraction on the outside, I'm actually subtracting the value. That value is 1 that I'd have to add to complete the squares. We take half of 2 and then square it, half of this middle term and then square it, and that equals 1. So that goes there. But I would have essentially had to be subtracting that 1, because when I distribute the negative, I would be subtracting the 1, and again, I don't get anything for free. So if the net effect of me doing all this is a subtraction of 1, then I have to counterbalance that by adding 1. So this is going to become 4. 3 plus 1 is 4 minus, I'm going to now factor this into x plus 1 squared. And so now I see that a is equal to 2. Okay, this is 2 squared, and the x squared is really an x plus 1 squared, and so we're going to have to deal with the fact that it's x plus 1, probably by a u sub. Okay, but let's put this guy now back into the integral. So we have the square root of 4 minus x plus 1 squared dx. Okay. Okay, let me do a u sub on this straight away so that we can get something that allows us to go to a trig sub. So u is equal to x plus 1, du is equal to dx. Okay. And so this is going to, and so this implies that x is equal to u minus 1. So I'm going to have to plug that in for the top. This is u minus 1 over the square root of 4 minus u du.
Sorry, Professor, but isn't it technically 4 minus u squared?
Yeah, thank you. 4 minus u squared, thank you. Okay, 4 minus u squared du. So now I'm going to break this up into two integrals. This is going to be the integral of u over the square root of 4 minus u squared du minus the integral of 1 over the square root of 4 minus u squared du. Okay, this is just a regular straight u sub. So I'm going to change my variable. I'm going to call this a v sub. So let's let v equal 4 minus u squared. Dv is equal to negative 2u du. Divide by negative 2. I get my u du there. So let's change this into v's. So this is going to become negative 1/2 1 over v dv. Sorry, 1 over the square root of v dv. Okay, integrate. Okay, and then this is going to be negative 1/2 times v to the negative 1/2. Okay. Now let's integrate that dv. And so this is negative 1/2, add 1, I get 1/2, multiply by the reciprocal, I get 2, v to the 1/2. Okay, I could put a plus c if I want. Okay, the 2's cancel. I'm left with negative times v to the 1/2. That's the square root of v plus c. And then what was v? V was 4 minus u squared. Okay, but what was u? U was x plus 1. So we could go 4 minus x plus 1 squared. But again, what was that? Now, in the very beginning, what was this? Why did we put it in this form? Well, in order to integrate, but if we leave our toys the way we found them, this really is 3 minus 2x minus x squared. Okay, so plus c, plus c, plus c. Okay, so now that one's done. This one, we could do a u sub on it. Okay, it is, however, number 17 on the chart of integrals that I gave you. So if you look at number 17, it just tells me, hey, this is an inverse sine function. Okay, the integral of this thing is the inverse sine of u over a. Okay, where a here is 2, so it would be u over 2. So if we wanted to do the trig sub, we can. Let's just do a little practice on that. Otherwise, we could just use the fact that this is an inverse sine. Okay, integral of the inverse sine. Or sorry, the integral of 1 over 4 minus u squared is inverse sine. But let's do the trig sub just to give us some more practice with that. Okay, so this is going to be 2 as my hypotenuse, u, and then this guy down here is going to be the square root of 4 minus u squared. Okay. Okay, this tells me that the sine of theta is equal to u over 2, or u is equal to 2 sine theta. Okay, so if I take du, that's 2 cosine theta d theta. Okay, I'm going to integrate. Okay, this is going to become 1 over the square root of 4 minus u squared, which is 2 sine theta squared, times 2 cosine theta d theta. Okay. And so this becomes the integral of 2 cosine theta over the square root of 4 minus 4 sine squared theta d theta. This becomes the integral of 2 cosine theta all over the square root of 4 times 1 minus sine squared theta d theta. But 1 minus sine squared theta is cosine squared. So this is 2 cosine theta over the square root of 4 cosine squared theta d theta. And we get the top and the bottom to be the exact same thing. So this becomes 2 cosine theta over 2 cosine theta, which is just 1. So this goes to just the integral of 1 d theta. And that's just theta plus c. But what is theta? Well, the sine of theta was u over 2. So theta would be the inverse sine of u over 2. So the sine of theta is u over 2. So theta is equal to the inverse sine of u over 2. Okay, so this is going to be the inverse sine of u over 2 plus c. But what was u? U was x plus 1. That's what u was. Okay, so this is the inverse sine of x plus 1 over 2 plus c. If we put it all together, a constant plus a constant is a constant, so we just get one constant. Okay, this is going to become negative square root of 3 minus 2x minus x squared minus, because we are subtracting here, right? Yeah, we're subtracting from the top. Okay, minus the inverse sine of x plus 1 over 2 plus c. Okay. Okay, and that is number 5 and section 3.3.